The graphs of 4 derivatives are given below. Match the graph of each function in a through d, which is on the left here, and then we're going to match it with the graph of its derivative over here with the Roman numerals from 1 to 4. Okay, so let's talk about what we need to do in order to determine which function matches with the derivative. Now, the derivative is estimated by drawing a tangent line at the point x and f of x with the approximating its slope. So you want to look for horizontal tangent lines, and these are the x-intercepts of the derivative function and where that'll be located. So let's first start with one here. So here is our function a. Okay, so let's determine where our slopes are 0. Okay, so if you take a look at the function in a, it's decreasing from left to right. And then here is going to represent an x-intercept, and then this value is going to represent an x-intercept. So you can see here that this value is a negative value, and that is a positive value. So if you take a look down here, this is where our x-intercept is 0. And then over here, we also have an x-intercept at 0. So that means we have 2 x-intercepts. Okay, and the next step is to look for sharp points, and these cause a discontinuity in the derivative function. Well, if we take a look at this one, we don't have any sharp points. So this is not going to have a discontinuity anywhere. Okay, and now what we want to do is, in step 3, the derivative function is going to be positive where the tangent lines of the function have positive slope, and negative where the tangent lines have negative slope. Okay, so now let's take a look at the slopes. Okay, so if you notice here, here's the slopes, and it's going down from left to right. So we're just estimating here, but if we wanted to estimate here, let's say that this is like a -8 slope, and then we come down to, like, let's say -4, and then this becomes -2. Remember, that's a rise over the run. And then eventually what's going to happen is that we're going to get to that tangent over here, which is 0. Now, since that tangent over here is going to be 0, now we can see what happens with these negative slopes. So you see here, -8 is now going to come down here. So this -8 is now going to be the -8 located, let's say, on that y value down here. And then the -4, and then -2. So therefore, you can see that this negative value is now getting to that x-intercept. So now, once we see that we're getting to that x-intercept that's crossing the x-axis where this slope is 0, now we are starting to now increase. So here, we are going to then, our slopes, right, are going to now start to increase until it gets to that 0. So you can see here that our slopes are now increasing. Now when it gets to 0, you can see now it's starting to decrease until it gets to the next slope where it's 0, which is the x-intercept. So in this case here, we can see that if this was 1, this was 2, okay, and then now it's going to start decreasing again over here. So now what's happening is once we hit this 0, now here is our x-intercept, here is 0, so we can see it's decreasing. So over here, what I'm going to do is I'm going to write, okay, this is decreasing slopes, so I'm going to write negative, okay? And then over here, this was an increasing slope from here to the 0. So from this value to 0, we can see it's increasing. And now from 0 to this value, it is decreasing slope. So that means now we're decreasing until we get to that x-intercept. And now from here, now it's going to be decreasing. So our slopes are going to be decreasing, which means that's what we're happening over here, which is our decreasing slope. So therefore, this is going to represent our derivative for a. Now let's just write this out. So we know that the derivative here, it says going from left to right of the function, the slopes of the tangent to the graph, they start out negative, and then it becomes 0, and then it becomes positive when it gets to 0, and then from 0 it becomes negative again. And then the actual function follows in the graph 2, and it follows the same pattern. So therefore, that's how we match A with 2. Okay, now, for the next part, we want to take a look at this graph. Now remember, we want to look for horizontal tangent lines, and these are the x-intercepts of the derivative function and where it'll be located. Well, in this example, we don't have any tangent lines. So we're going to go to step 2 and look for sharp points, and these cause a discontinuity of the derivative function. So let's go ahead and take a look. So we have a sharp value here, and then we also have a sharp point there. So what that means is at this value here, we're going to have a discontinuity or a hole here. Okay, and likewise over here, we're also going to have a discontinuity, which is a hole there. So let's take a look here. So B matches with graph 4 because again we have our discontinuities, but if you notice, since going from left to right, the slopes of the tangent to the graph, they start out at a fixed positive quantity, and then suddenly they become negative, which is going from here to here, and then positive again. So the discontinuities in the graph of 4 indicate the sudden changes in the slopes of the tangents. So again, here is a fixed quantity, and then it drops. Okay, and then we have our fixed quantity here, and then it starts increasing again. So you can see here, let's take a look. So here you can see that it's increasing at a fixed point. So there it's increasing, and then it decreases. So it drops, and then now it's decreasing, and then again now it's going to increase at that value. Okay, now let's take a look at part C. So for part C, again, we want to determine looking for any horizontal tangent lines. So we have a horizontal tangent line, which is right there, and that's going to be the x-intercept, and that is the x value of 0. So therefore, there is our x-intercept on our derivative function. Okay, now if you take a look at all the values of x that's less than 0, okay, we can see that our slopes are decreasing, which are negative. Okay, and then they start to increase when they get to 0. So here they start to increase here. So you can see here, here's our graph. Okay, we're starting at that value, then it decreases, and then it increases until we get to our x-intercept. Okay, now for all the values on the right hand side, you're going to see that then it increases, and then it's going to start decreasing as far as slopes are concerned. So if you take a look at here, there at this part here, we can see that our slopes are increasing, and then they round out to then decrease. So you can see here, it's similar here. You can see that we are continuing an increase, and then it starts to decrease as far as the slopes are concerned. So therefore, we would say the following. Since the slopes of the tangents to the graph are negative for when x is less than 0, and positive for when x is greater than 0, as are the function values of this particular graph as well. Okay, now let's take a look at the last one, which is D. Okay, so the first thing again we want to do is look for horizontal tangent lines. And again, these are where the x-intercepts of the derivative function will be. So there is a horizontal tangent line, there is a horizontal tangent line, and then there's also a horizontal tangent line. So that means that is going to be the x-intercept on the derivative function, and then we have another x-intercept on the derivative function, and then we have another x-intercept on the derivative function. Okay, and so now we need to take a look at the slopes. So from the slopes here, okay, you can see that what's happening with this slope. Well, you can see that the slopes are increasing. It's positive until it gets to that slope of 0. So here is positive slopes, and then it gets to a slope of 0. So it's positive and positive and positive until it gets that slope of 0. Okay, and then it continues. Now here it's starting to now decrease until now it's decreasing here, and then the slopes start to increase when it gets to 0. So that means it's continuing to decrease, and then it's going to go back up and increase to when it gets to the next x-intercept of 0. Okay, and then from here we can see that it starts to increase. Here we can see that the slopes are increasing, which is positive, and then it's going to decrease until it gets to that negative slope. So again, it's increasing, and then it's decreasing to the next x-intercept, which is 0, and then from here, then it just continues to fall, which we have negative slopes, and therefore there is our graph. So we can see that D matches 3, and since going from left to right, the slopes of the tangent to graph D are positive, and then it goes to 0, and then negative, and then to 0, and then positive, and then to 0 again, and then negative again, and then the function then continues to decrease.